Hello students, how are you? I hope you will be very fine students. Students, today we are going to discuss about one of the most important topic of your board classes, of your competition classes, that is motion. Yes, this motion topic will be discussed in this video. Firstly, we can define the motion. What is motion? So we can say that if the position of any object is changed with respect to time, then the object will be known in the motion. Here is the sense of with respect to time is time change. So we can say that in other way, if the position of any object is changed with respect to the time change, then the object will be known in the motion. But it is not the proper definition or complete definition of the motion. For example, if you are travels inside the bus, then you will be in rest with respect to all those travelers who are traveling inside the bus. But if any person or any observer are stay outside the bus, then you will be in motion with respect to that person who are stay outside the bus, who are stand outside the bus. So for the motion of any object, the most required thing is observer, and the observer should be in rest or stationary object. So we can say that motion is the controversial word, because in case of motion or in case of rest, we cannot assume, we cannot claim absolute rest. Why? If you are rest with respect to all those observers or stationary object or rest object who are lies in the earth surrounding to us. But if the any person who travels in the space, then that will be observe you as a motion. Why? Because the earth is continuously moving on its axis. Earth is not in rest. So absolute rest will not be possible, because you will be in motion with respect to that person who flies in the space. So we can say that the motion is the controversial word. But the motion is related many terms, that is distance, that is displacement, that is velocity, that is acceleration, that is instantaneous velocity, instantaneous acceleration, all those terms. Generally, motion are two types on the basis of position and time: uniform motion and non-uniform motion. For example, uniform motion. If the any object travels equal distance in equal interval of time, then the object will be in the uniform motion. Now we can see this on the board. For example, if in 0 to 1 second, 1 to 2 second, 2 to 3 second, 3 to 4 second. Here in the all the cases time interval is 1 second. 1 minus 0, 1 second, 2 minus 1, 1 second, 3 minus 2, 1 second, 4 minus 3, 1 second. And the distances are in each interval is 20 meter, 40 meter, 60 meter, 80 meter. First interval of time, 1 second, is 20 meter, 40 minus 20, 20 meter, 60 minus 40, 20, 80 minus 60, 20 meter. So you can see in each and every time interval which are same, which are 1 second, is 20 meter, 20 meter, 20 meter, 20 meter. So this motion will be the uniform motion. For example, non-uniform motion, we can say that if the any object travel unequal distances in equal interval of time, then the object will be known in the non-uniform motion, and the position of the object is 20 meter, 30 meter, 50 meter, 80 meter. Now we can say that in first time interval 20 meter, in second time interval 10 meter, 30 minus 20 10 meter, 50 minus 30 20 meter, and last time interval 80 minus 50 30 meter. So this will be the example of non-uniform motion. So we can say that non-uniform motion, the distance will be unequal in equal interval of time, but in the uniform motion distances are equal in each equal interval of times. So we can say that the motion are generally two types, uniform and non-uniform motion. But the some terms which are related with the motion, now we can define the distance. The length of path is called distance. रास्ते की लंबाई को डिस्टेंस कहते हैं या दूरी कहते हैं. But what is displacement? The shortest distance between 2 points is known as displacement, or minimum distance between 2 points is known as displacement. Distance and displacement are the different terms. What is the difference between these two? Distance always will be greater than displacement or equal to the displacement. For example, if we travel from here point A to point B and then point B to C and then point B to D, then point C to D, in first A to B 20 meter, firstly A to B 20 meter, B to C travels 10 meter, C to D travels 15 meter. The distance travels A to D is 20 meter, 10 meter, 15 meter, 30, 45. So distance is your distance in this case will be your 45 meter. What is the displacement? What will be the displacement? Displacement will be this. A to D. A to D. For example, this is 30 meter. But remember this, it will be the vector result. This will be find with the help of vector loss. But we can consider, for example, 30 meter. This 30 meter is less than 45 meter. But this will be the displacement. Displacement. Now we can see it is 45 meter and it is 30 meter. Here distance is greater than displacement. But if the object travels only A to B, only A to B, and this is your 20 meter. In this case, the distance from A to B will be 20 meter and displacement A from B or A to B will be also 20 meter. So we can say that in this case the distance and displacement will be equal or same, and here the distance and displacement are different, but we can say that distance is greater than or equal to displacement. Distance is greater than or equal to displacement. So we can also say that distance upon displacement will be greater than or equal to 1. So the ratio of distance and displacement is greater than or equal to 1. But displacement upon distance is less than or equal to 1. These two terms is very important from the board point of view, for the competition point of view. The ratio of distance and displacement is greater than or equal to 1, or the ratio of displacement and distance is less than or equal to 1. So we can see this distance and displacement and difference between these two. In other way, the difference between this distance and displacement can be also expressed as, also defined as, also explained as on the basis of vector and scalar. What is the vector? Vector are those quantities, vector quantities are those quantities which have direction and magnitude. But scalar are those quantities which have only magnitude, not direction. The distance is without direction quantity, only magnitude. So the distance is scalar, but displacement having direction and magnitude. So displacement having both direction and magnitude. And displacement is the vector quantity. If the any quantity having direction and magnitude both, then it is not enough for the quantity becomes to vector. Because if the any quantity having direction and magnitude both, the quantity should also have obey the vector laws. So the direction and magnitude is not enough proof for the vector quantity. For example, current having direction and magnitude both, but current is not the vector. Why? Because the current does not obey the vector laws, because current does not follow the vector addition laws. So the current is scalar, but current having direction, so the current is not completely scalar. If the quantity having direction and magnitude but does not follow the vector laws, then the quantity will be tensor. So the current will be the tensor quantity. For example, if you have any question, what is the current? The current is a quantity. Your option are vector, scalar, your third option is tensor, and fourth and last option is none of these. Then you can pick, then you should be pick tensor, not scalar, not vector. The question is current is the quantity. Your option are scalar, vector, both scalar or vector, and fourth option is none of these. Then you will be pick, then you should be pick scalar. Yes, it is the idea for the scalar and vector. So scalar quantities examples are electric current, mass, time, temperature, work. These quantities are the scalar. What are the vector quantities? What are the examples of the vector quantities? Force, electric field, velocity, acceleration, momentum. So thanks for watching this video. Keep watching my videos for more information.